Hello, welcome to this video produced as part of the Further Maths Support Programme's material for A-Level Maths and Further Maths. This one focuses again on work, energy and power, and in particular on motion in inclined planes. We begin with a question with some numerical values and a picture which gives a modelling analysis of what's going on. It's supposed to represent a winch pulling a crate up a slope where there's a frictional force. Let's just check through what this diagram is saying. We've got the speed v, and that later in the question is what we're interested in working out. And then we've got the tractive force Ft, the resistance force Fr, we have the weight, and we have the normal reaction force. Now, as regards the context of energy and work, the normal reaction force, being at right angles to motion, doesn't contribute at all. As regards the work analysis, the weight force can count its contribution through the change in potential energy. So we can use the usual work done equals change in energy argument to deal with this situation. So it starts off by asking us what's the work done by the force Ft newtons in the time given. Well, since we know the power and we know the time, since power is the rate at which work is done, it's a bit like calculating distance from velocity. It's essentially a matter of multiplying the two together. So we've got 6,000 watts. Notice the inconsistent unit, so we've got to change it to 6,000, and then times 50. That will give us the number of joules created by accomplished by the driving force in that time. So there we are, 6,000 times 50 gives the 300,000, and note the point I made about the units being made consistent before we do any calculations. So the work done, set in context, is 300 kilojoules. Notice again I've changed the units because 300,000 is far too large to quote. Now the question is, what's the resistance to the motion of the crate up the slope? We're going to do this by using a work energy argument. So we already know that the work done by the force Ft, we just calculated that, so we can use the work energy principle again. The work done by the tractive force, that's what we worked out, and the work done by friction, that's how we bring in the unknown Fr, which is the resistance, is the gain in potential energy. So the work done by the tractive force, that was 300,000. Notice I've gone back to the essential consistent units, that's joules, plus the work done by friction. Now friction is opposed to motion, so we're going to have minus Fr, and that will be times the distance up the slope, times 25. That will be equal to the gain in potential energy, which will be 1600 G, times the change in height from the beginning to the end. I'll put the cross in there so that we don't forget. Now here we're told that the distance up the slope is 25 meters, and we've got a right angle triangle there. We want to know what the increase in height is. That will be, as it usually is, 25 times sine 35, using the opposite over the hypotenuse. 25 times sine 35. Now that somewhat complex string of figures has only one unknown in it, so it must enable us to work out what Fr is by solving the equation. So there's the equation I obtained from my argument, and what we will need to do now is solve that. So here we go, we make Fr the subject. Notice that you can divide by 25 readily. You can readily divide 300,000 by 25, and the 25 cancels out here. So it's easy to see that we're going to get that simple expression for Fr. So we work it out using the calculator, full display as much as I can be bothered to write, and then round it to 4 significant figures. So the answer in context is that the resistance to motion, notice again my change of units, is 3.006 kilonewtons. In this area you can have a field day with different units. The key thing is to remember they're consistent, and that's probably one of the most important points about this whole presentation. Now, another aspect of this, just before we leave it, is that we could have worked out what FR was by using F equals MA along the slope. MA, well, the MA term is trivially zero because we're talking about constant speed, so there must be a force balance. Then we can easily resolve along this line, and that will allow us to work out what FR is. So that's an alternative approach. Well, that concludes this video presentation, which was on the motion of inclined planes, and it also concludes this second section on work, energy and power.